the original equation, we were given the displacement function, which is s equals 24t minus 0.8 t squared. To find the velocity of this equation, we take the derivative of it. So velocity, which is the first derivative, equals 24 minus 1.6 t. And this is your velocity. Now we're going to try to find the acceleration of this. Well, to find acceleration, you take the next derivative, so it'll be the second derivative of our first equation, or just the derivative of velocity. And that equals, so acceleration equals a negative 1.6. And that's how you find velocity and acceleration.
To find when the rock reached its highest point, we'll take the velocity, v equals 24 minus 1.6 t, and set it equal to 0. And then you solve that for t, and you get t equals 15 seconds. The rock reached its highest point at 15 seconds because that's when the velocity equals 0.
To find how high the rock went, we will use the answer in the previous problem, which is 15 seconds. So to start, we'll copy down our original equation, which is s equals 24t minus 0.8 t squared. And we will take the answer from our previous problem, which is 15 seconds, and plug it in for t, which gives us s equals 24 times 15 minus 0.8 times 15 squared. This gives us s equals 360 minus 180. And if you finish solving that, s equals 180 meters, which is how high the rock went at its maximum point.
For part D, we have to determine when the rock reaches half of its maximum height. To do this, we have to figure out where half the maximum height is. So we take our maximum height, which is 180, and divide it by 2, which equals 90 meters. Then we take our displacement formula, which is s equals 24t minus 0.8 t squared. We substitute 90 into the equation as our displacement, and we're going to solve for t, which is time. You subtract 90 from both sides, so you have a quadratic equation. And this quadratic equation would be very difficult to factor, so we're going to use the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We insert our values to where we have x equals negative 24 plus or minus the square root of 24 squared minus 4 times negative 0.8 times negative 90 all over 2 times negative 0.8. If you solve this, we get x values of x equals 4.394 and 25.606 seconds. This means that on the way up, the rock reaches half of its maximum height at 4.394 seconds, and on the way down at 25.606 seconds, it's halfway down.
Now we are going to find how long the rock stayed in the air. Earlier we found that the rock reached its highest point at 15 seconds. So we know that 15 seconds was the halfway point. So in order to find how long the rock was in the air, we take 15 seconds and multiply it by 2, which gives us 30 seconds. And that's how long the rock was in the air. To find this, we would first write the original equation, which is S equals 24t minus 4.9t squared. And then we would find the derivative of this, which is velocity. So velocity would equal 24 minus 9.8t squared. And then we would set this equal to 0. And solve this out so that it equals then the final answer is going to be 2.449 seconds for the time that the rock was the highest. And then to find the height, we would plug this number into our original equation. So, like this. And then we solve this out to get the answer of 29.388 meters. And that is how high the rock would go.